Hey guys, welcome back. Today we're going to talk about if a graph is a function because I don't know, but I want to. So, if we have a graph like this, oh yeah, look at my straight line drawing skills, and we, I don't know, have a line like so, just like our basic line. How can we tell if it's a function or not? Now, the way I'm going to tell you is called the vertical line test. I don't have a long, straight object with me, but if I did, actually I do, hang on, let's use this book, okay? So, we're going to take this, right, we know what a vertical line looks like, and we're going to bring it all the way across. And if at any point in this line, we have it overlapping itself like this, and we have two spots on that vertical line, it's not a function. What I mean by that is, if I have my eraser, okay, so for this, I know right away that this is a function. This is because we don't have it overlapping itself. So, if I were to go through the entire time, only one point is going to be on x at all times. Okay? Which is pretty cool. Now, if it weren't a function, it could look something like a circle. A circle has 2 points on the x-axis at all times. This is not a function. Now, if we were to take let's say we had random points on a graph. We had one here, 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 and here. These are just random points on a graph. I don't know if you can see those. But what I can tell is that none of them are overlapping each other on the x-axis, which means it's a function. I can go all the way through here and have none of them hit the x-axis at the same time. And that makes it a function. So it doesn't matter if the lines are connected or not. It can still be a function. There is some special cases, though, that you might want to look out for. One of them being if we had an asymptote. Now, an asymptote is still a function. It just might not look like it. See, an asymptote basically gets closer and closer to this line, and it will never touch it. So it will get closer and closer to its asymptote and never touch that line, which is really cool, but might be confusing. So this, is 0, 0, right? On the x-axis, it is it is 0. Meaning, this line on this asymptote will never touch 0, okay? It'll never touch 0, although it's going to get extremely close. And this line will also never touch 0. Therefore, if I were to run a vertical line along here, there's no 2 points that'll be on the x-axis at the same time. Because I know it looks like these two are on the same line, but they're not, because they'll never reach that number. Okay? And then the other case I want to talk about is if we had an open circle, which are also pretty cool, but can be tricky. Because if I were to have 2 lines, let's say I had one here like this, 2 line segments, my bad, and another one here, okay, those don't look like they're on the same point. We're going to say they are, and we say those are both on the same point. This is not a function, because at some point, there's going to be 2 on the same x-axis point right here, okay? Now, if instead, where's my eraser? Oh, here it is. If instead it looked like this, and we had an open circle, this is different. An open circle means it's going to get closer and closer to this number, as is really not there, to this number here, to the x-axis, but never quite touch it. Just like the asymptotes, actually. It's going to get closer and closer, but never actually touch that number. So, this is a function, because, sure, this point here might be almost at this number, but it will never touch it. Therefore, these two will not overlap. That is how to tell if a graph is a function or not. Anyway, y'all, I don't know, go touch some grass, and may the sports be with you.